Hi all, and welcome to this webinar today, which is hosted by ORS Consulting. My name is Morten Petersen, and I'm sitting here, at least virtually, with my colleague Matthias Wolf, and we are excited to do the webinar today. So today we will dive into a trending topic for asset owners and different stakeholders in the process-related industries. So today we will be talking about cybersecurity for industrial control systems and OT. And we will focus on why and how it needs to be integrated into risk management processes and process safety. So what are we talking about today? First of all, Matthias will share some thoughts about and definitions about industrial control systems and the difference between information technology and operational technology. Then I will say some words about how we integrate cybersecurity into overall technical risk management processes and the relation between cybersecurity and process safety, because it's all linked together, as we will see today. Then Matthias will share some details about cybersecurity methods and how we work with it, referring to some standards. And finally, we will have a Q&A session in the webinar today. So in the Teams application, you will find a Q&A symbol. So please share some questions for us, and we will try to respond to some of them. And it's also possible to tick off a box so that you can stay anonymous. So I hope that this sounds interesting, and if it does so, please stay tuned. So before we start digging into the technical details here, I would like to present ourselves and the company quickly. So ORS Consulting is an advisor within what we call industrial risk management. So this company is based in Denmark, Sweden, Norway, the UK, and Turkey. And we have approximately 80 specialists working with risk and safety. And the areas we're talking about today, process safety, cybersecurity, and technical risk management and functional safety, it's all within our core service areas. And again, my name is Morten Nilstad Pettersen, and I'm based in Oslo in Norway, and working as a principal consultant. And I also have the role as the managing director for the company. I have approximately 15 or more than 15 years experience with risk and safety, and been working with industries such as oil and gas, chemical industries, and other process-related industries. Been working with areas such as process hazard analysis, functional safety, and cybersecurity. So that's short about me. And let's travel south to the west coast of Denmark and Esbjerg. Matthias, would you please present yourself?
Yes, I am Matthias. I'm a consultant at ORS Consultant. I'm connected to the Esbjerg office in Denmark, as Morten mentioned. I primarily focus on ICS, cybersecurity, and functional safety. So I'm trying to make sure that the industrial control systems are secure and by that also safe. And I work with different standards like IEC 62443, 61508, and 61511. And I have experience with cybersecurity risk assessments and process hazard analysis, like HACCP and LOPA, and also hazard identifications, open as hazards. Yeah. And if you go to the next slide, Morten, yeah.
Yeah.
So before we dive into the subject today, we want to set the scene here. So our focus is on the operational technology, which is the OT, and the ICS, which is the industrial control systems. But to understand its cybersecurity challenges, we need to first kind of differentiate it from IT. So on the left here, we have the IT, which is about protecting confidentiality, integrity, and availability. And on the right side, OT is about keeping industrial operation running safely. So you can think of an ICS system as the brain and nervous system of a process plant. So if it fails, the impact is not just about data loss; it's about safety. So we are talking about real physical consequences, potential for major accident hazards, environmental damage and production loss and downtime here. So in IT, some downtime is acceptable, but in ICS systems here, downtime can mean more dangerous process conditions. So that's why availability comes first, integrity comes second, and this is to avoid unsafe process conditions or deviations. So confidentiality is still relevant, but safety is what drives everything here. So when we talk about ICS cybersecurity, we're not just talking about protecting information. We are trying to protect the people and the environment and the asset, the plants we're working with. Yeah. And so IT OT convergence is to talk about why this subject is becoming more and more relevant. So IT OT convergence refers to the integration of IT systems which manage data into OT systems which control physical processes in industrial environments. So traditionally, these systems have been separated, but there has been some advancements in the connectivity or in the industry that has created some new possibilities here. So despite there is some new cybersecurity challenges with this integration, the industries we're working with is continuing to integrate IT and OT due to the significant operational benefits they could have. As you see here, there is faster decision making, so something like real-time data sharing that could improve visibility across operations and potentially reducing some delays. We have predictive maintenance and remote monitoring, something like remote access and analytics to help detect failures potentially before they occur, to minimize downtime here. We have the industrial Internet of Things and cloud computing. So we have a lot more connected devices that generate a lot of data, and we need some cloud computing to process all this data, and it could be improved by AI-driven optimizations as well. Then we have the digital twins, which is virtual models of physical assets to simulate and optimize industrial processes before you're going out and doing some real-world changes. So a balance must be made between the convenience and the security or the risk to ensure resilience for the system. And I think Morten is going to talk a bit about how we manage some of the risks in an ICS cybersecurity context now.
Exactly, Matthias. So as we have heard from Matthias, there is an accelerating complexity of the ICS infrastructure across the industry. There is an increased IT-OT convergence, and with the geopolitical situation, there is also an evolving threat landscape. And if we summarize it, it means that there is a need for having a robust and thorough risk management process covering the ICS systems and topology. So here is a question for all of us. How can we ensure that we have an acceptable risk when we are adding ICS cybersecurity into the overall risk management and process safety? So remember that the risk, when we're talking about risk, it's a combination of likelihood and consequence. So when we are talking about cybersecurity, it's not only about understanding the consequences or the vulnerability of cyber-related threats, but it's also important to get the full risk picture by adding the likelihood into the fraction. And 2 decades ago, regulators and the industry was developing a framework and different risk-based methods covering the extensive use of instrumented safety systems. And the result resulted in what we call functional safety and SEAL-related methods. And this is equivalent to what is happening today. That now there is a similar process of developing risk-based methods, and regulators are working on different principles for ICS cybersecurity. And the bottom line here is that we need to know if the risk is acceptable or not, and how we mitigated. So risk is something that we can control, we can reduce it, but as long as we have a process plant and also connectivity, as Matthias pointed out, we cannot eliminate it totally. So looking more into the technical risk management and how we safeguard process plants. So in this presentation, we are talking about this from a process industry point of view, but basically it's applicable for all industries where you have control and safety systems controlling the environment. And in the process industry, you typically have liquids, gases, it can be pressurized, and if there are leaks or what we call loss of containment related scenarios, these are events that can escalate and result in major accident hazards. And what you see on the picture here is what we call a bow tie model, which is a good way of illustrating barriers and also powerful for working with barrier management. And it shows the relation between the threats and the ultimate consequences. So for a process plant, typically the undesired event we're talking about is loss of containment. Noting that there could be other scenarios, but let's focus on this. And what we can see is that for a loss of containment scenarios, there are multiple threats relevant for a process plant. We are talking about human errors, we're talking about equipment failures, we're talking about control system failures, and we have to include cyber attacks and cyber-related threats into the equation. And ultimately, if the barriers that will prevent that these threats are resulting in loss of containment, if they fail, we could end up in a loss of containment situation, which could then escalate into consequences related to personal, environment, financial loss, or reputation. So let's have a bit closer look into the process safety part of it and how cyber is related to it. And in risk management, we appreciate some food-related risk management models. So let's start with the Swiss cheese model. It's a good way to illustrate barriers and barrier management. And it shows how a potential hazard can result into an accident or scenario if the barriers fail to control the situation. So when we're working with barrier management and with risk and safety, it's all about ensuring that you have sufficient layers of protection, but also that the layers of protection are robust and will fully prevent or mitigate the scenario. And the challenge with cyber-related threats and cyber attacks is that this will and may challenge the standard barrier envelope that we have for a process facility, both in the way that threat actors may have the possibility to bypass, disable, or degrade the more standard barrier envelopes, and that's why we need to have a holistic and integrated approach to this. So looking at another model, which is the onion model, and this shows also the different barriers and barrier envelopes we typically have for a process plant. So focusing again on loss of containment related scenarios, in order to avoid these scenarios, first of all, we need to ensure that we have a robust process design. It's about material selection, selection of equipment, and so on. If we have a process upset that has the potential to become a loss of containment scenario, first of all, we typically have a basic process control system. So a control system that will act and avoid the scenario from escalating by closing valves, turning down the temperature, and so on. If it fails to control the situation, and if the process goes beyond its operating envelope, we typically have alarms, and the operators are trained to react to alarms. If that also fails, we normally have what we call a safety instrumented system. So it's a standalone safety system that will be triggered and put the system to safe state. I will come back to that. Then if that fails, often we have mechanical protection. And if it still results in a loss of containment scenario, then we are reducing the consequences by physical containment. We're talking about bunding, for instance, fire and gas system, emergency preparedness within the site, and also emergency response towards the community. And when we're talking about cyber threats, cyber attacks, it's possible, or it's important here to acknowledge and understand that cyber threats may have the possibility to disable and impair several of these barriers. So what you can see here is, in theory, the basic process control system can be vulnerable for cyber attacks, alarms, the safety instrumented systems, as long as we have connectivity and it's not totally isolated, and fire and gas system. So this is another good reason for managing the cybersecurity for ICS into the overall process safety management. Again, a bit closer look and an example here about what we are talking about when we talk about controlling and safeguarding a process system. So when we are talking about ICS, industrial control systems, here we include the process control system and the safety system, and there could be other systems as well. And here you can see a quick example on how we typically safeguard a facility. So let's imagine that you have a vessel, it's pressurized, it contains gas or liquids, and if it's overpressurized, it can end up in a loss of containment and a major accident hazard. And normally, or typically, you would then protect it by having a pressure control system. It could be a transmitter and realized through a PCS control system, PLC, that is taking some action, closing a valve or closing a breaker, something like that. If the situation is still escalating, you have a safety instrumented system where you have a dedicated pressure transmitter, dedicated PLC, and a dedicated final element. It could be a valve, circuit breaker, and similar. And when you design a safety system, it's typically designed according to IEC 61511 or 61508. We will not deep dive into that in the webinar today. And further on, in this example, you also have a mechanical overpressure protection, so a PSV that will open and relieve the pressure and avoid the overpressure scenario. And here it's worth highlighting that in this example, in theory, the PSV is the only non-hackable barrier. And this is an ideal case or a textbook example, but there could be multiple scenarios on a plant with less severe consequences or similar that is not protected by mechanical barriers, meaning it's important to safeguard and protect the PCS and SIS against unauthorized access. And before we start looking at methods and framework and so on, just highlighting some of the threats and the potential process-related hazards we are talking about when we are talking about unauthorized access or cyber attacks. 5 examples here. So in theory, it's possible to trigger process upsets and cause demand on safety functions. That's something we need to safeguard against to avoid that valves are turned, boilers are set to maximum, and so on. We need to safeguard against combined scenarios. So in theory, threat actors have the possibility to initiate scenarios, multiple scenarios at the same time. And if a plant is not designed for a scenario like this, it can be an escalating factor. Triggering damage of long lead items. If there is a process plant with compressors and other long lead items, it's important to safeguard the equipment. And also, in theory, we need to safeguard against manipulating and disabling the safety function. So the safety function is one of the critical barriers for a process facility. and we need to make sure that the barriers cannot be disabled or impaired. And finally, production shutdowns. Availability, as Matthias pointed out, is critical in multiple industries, and we need to safeguard the plants against any cause of production shutdowns. So I know, Matthias, you're eager to take over now, but before that, I will say some words about the compliance framework for ICS cybersecurity. So I'm sure that most of you have heard about the NIS2 directive for Europe, or NIS CSF2 equivalent in the US. And that's legislations and directives outlining the importance and the requirement to focus on cybersecurity and risk management for industries, also focusing on critical industries and infrastructure. But these directives are not outlining or describing detailed methods for how to work with ICS cybersecurity. So when we are working with ICS cybersecurity, and this is what Matthias is coming back to, we are talking about IEC 62443. And that's a family of standards. Today, we're talking about 11 standards outlining principles, methods, and so on for ICS cybersecurity protection. And the -3 group of standards, at the moment 3, is covering methods for cybersecurity risk assessment. So that's fundamental, and what Matthias will come back to. In addition, we have the ISO 27000 series covering IT systems, but there is some overlap between ICS and IT, so it's important to be aware of that one as well. And also we have for safety instrumented systems, we have the IEC 61511 and 61508 standards covering functional safety and design of safety systems. And in these standards, there are requirements to do cybersecurity activities, but again, they're not outlining specific methods for how to do it. So the 62443 is a highly relevant standard. So with those words, Matthias, now it's a good timing to dig some more into the methods for how to work with cybersecurity. So I'll leave the word to you, Matthias.
Yeah. So, well, cybersecurity in industrial environments does require a structured approach to prevent security gaps and to avoid cyber incidents, as Morten has just told us about. So this can be achieved by some different assessments, and here we are talking about the high-level risk assessment. We're talking about the gap assessment and the detailed risk assessment. For the gap assessment here, it's about evaluating compliance with, for example, IEC 62443, or it could be a corporate security policy, or a standard, or maybe some other regulation relevant for you. So the figure here is trying to illustrate the different cybersecurity assessment approaches for legacy assets and for new projects, and also approximately when they are expected to happen. So for the new projects, we have the high level, or the initial assessment, which is done early during the concept or early design phase. Then we have the gap assessment. It's carried out before the detailed design to check compliance with like the expectations of the cybersecurity, and then the detailed risk assessment is performed during the design phase. That is for the new projects or new assets. And for the legacy assets, the process often starts with the gap assessment to evaluate where the system is today versus the expectations we have to the cybersecurity for the system. And then the detailed risk assessment, which built on the gap assessment, is like diving deeper into the risks and the zones and the conduits here. And then, as a general rule of thumb, you could say that it's a good idea to repeat the detailed risk assessment and also the gap assessment no longer than what you would do for the PHA's revalidations. So this more structured approach here ensures that security is embedded in new projects to integrate it into the cybersecurity lifecycle, where the legacy assets are secured through compensating controls and kind of start that journey into the cybersecurity lifecycle with the gap assessment. And when doing these kind of assessments, it's a good idea to have some base documentation. And here we are often talking about the network topologies. So it's a visual representation of how devices and systems are connected. So it shows both the logical architecture, like how things are connected, and also the physical setup. Sometimes it also shows the physical setup. And the diagrams can range from very simple block diagrams to more detailed topologies. And it's important because before assessing cybersecurity risks, we need to understand how the system is built. So the diagram helps us to identify what is connected to what, how the information flows, and where potential vulnerabilities may be hiding here. So the security risk don't just come from, if you go back one, yeah. So the security risk here doesn't just come from the network architecture. They also depend on the physical location. So if we had an engineering workstation here, is that located in a secure room, or is it a workstation where someone could just walk up and plug in for example, a USB device? An example of a threat on that could be that you introduce some malware via a USB port here. There could be many entry points. So a network diagram is more than just the documentation. It's the foundation for understanding and manage cybersecurity risks. So you can think of it as a PNID for cybersecurity. Without this documentation, you're kind of blind on how things are connected and where things could go wrong. And then you can go to the next one. Yeah. So for the high-level risk assessment is the purpose here is to provide a broad evaluation of key systems and their exposure to cyber threats. So it's not an in-depth analysis. It serves more like a critical starting point for defining cybersecurity priorities. So it helps to identify the most relevant systems to focus our cybersecurity efforts. It's to prioritize areas based on worst case consequences. And it's trying to establish like an initial security level target for the different cyber assets. So we have some steps here. The first one is to identify relevant systems. Here we could utilize some safety studies like the PHA studies, LOPAS, HACCPs. Could also look into the HACCPs and see what we could get from that to determine where the cybersecurity risk should be assessed. Then we prioritize the key systems because we want to focus our efforts on the most critical systems to ensure that we are using our resources efficiently. Then we assess the different cyber assets. So we document the key cyber assets within the prioritized systems we have from the step before to establish like a solid foundation for the risk evaluation. And then we evaluate the worst case consequences. So we consider the impact of compromise for the cyber assets without assuming any safeguards or countermeasures for them. And then we set the security level target based on the consequence severity. So the high-level risk assessment focus its efforts on identifying the key risks early in the process. So it's trying to set the security priorities and help to set the foundation for the next steps and the detailed risk assessment. And when talking about risk assessments and how to do it, there is a point about the likelihood on the next slide here. The point here is that estimating likelihood is somewhat difficult in cybersecurity compared to process safety. So in process safety, we rely on the historical data, the historical failure data, like failures of a valve or failures of a pump breakdown. So cyber threats are often more intentional or targeted. So in process safety, a pump fails randomly, and in cyber, an attacker acts with intent, opportunity, and also capability. So that means we cannot assign probabilities in the same way we do in process safety. And so far, there's really no perfect answer to the likelihood question here in cybersecurity, but we can use something like effort level as a proxy for likelihood here. So here we are proposing that if you have if there's a low effort, there's a high likelihood. So if it's possible to make an attack, like using basic tools, unknown vulnerabilities, it could be default passwords or exposed remote access. Anyone with like minimal technical skills could do this, or even maybe bot networks could also do it. And for medium effort and medium likelihood, it's more skilled attackers like cyber criminals. They could be using something like phishing attacks to get access and move inside networks and manipulate systems. And for the high effort and low likelihood here, we're talking about more sophisticated attackers like nation-state attackers targeting safety systems. And they require, of course, deep knowledge of the systems and the technology, and major allocation of resources as well. So there are not many nation-state attackers, and that's why it's a low likelihood here. And if we go to the next step, we have the detailed risk assessment. So after the high-level assessment has given us the big picture, the detailed risk assessment takes over to kind of drill down into the specifics, you could say. So where the high level focused on worst case consequences and helped us to prioritize the systems, the detailed assessment is more about understanding exactly how those risks could materialize and what we can do about them, like the countermeasures here. So another important shift is also that we no longer just talk about systems. We organize the cyber assets into zones and conduits, where the zones helps us to group assets with similar security needs, and this limits how threats can move inside the network, and the conduits define how the communication path is between the zones. So that's where we apply security controls to manage the data flows. So this gives us a better understanding of where the weak spots, weak points are in the system, and how threats might move through the system or the environment here. We also look at the final security level target here for the devices in each zone and conduit. And just like in the high level assessment, this work should be tied back to the process safety work. So we want to make sure that cyber risks don't compromise our safety functions. So this should be aligned with our PHAs, the HACCPs and the LOPAs. So in the high level, we set the stage, you could say, and the detailed risk assessment gives us the technical basis for like the real cybersecurity improvements. Yeah. Then it's you again, Morten.
Thank you, Matthias. And I would like to share some key takeaways when we're talking about ICS cybersecurity. And a key message from the webinar today and what we have talked about is that cybersecurity is not limited to information security. So when we're talking about cyber threats for ICS and process system environments, cyber threats can lead to process safety incidents, and that's why we need to integrate it into the overall risk management processes and the evaluations done for the plant. And with the IT-OT convergence, the increased complexity and the evolving threat landscape that you touched upon earlier today, Matthias, there is a need to use what we define as risk-based methods. And one remaining question here is then how can we integrate and how to integrate the ICS OT cybersecurity to the overall risk management process? And there is no right or wrong or specific answer to it, but to give some guidance on how to integrate it into the ICS or into the risk management process. First of all, it's important not to have an organizational silo between the discipline working with ICS cybersecurity and other related disciplines such as process safety process, and so on. It's all linked together, as we have seen today. And barrier management is a well-founded and well-established way of doing risk management for plants and different industries, and integrating this into the overall barrier management processes is fundamental. And there's also possible, and there are different ways of integrating also ICS cybersecurity into other process safety related methods, such as having a structured way of ensuring that you have non-hackable barriers, or barriers robust and inherently safe against cyber threats for critical scenarios. So one of the examples here. And we have talked a lot about barrier management during the webinar in different ways. And just to highlight about a typical barrier management process for a facility. So barrier management is something we do across different threat areas and different subset of activities. So for instance, functional safety is a part of barrier management and how to avoid and prevent against major accident hazards. So a typical barrier management process is, initially, we need to map and understand the major accident hazards we have for the plant. And here, cyber threats are obviously part of the bigger picture here. Finally, or following that, when you have established an overview of the hazards, there is a need to identify barrier functions and barrier elements. And for cyber threats, there are specific barrier functions and barrier elements that are relevant to include in this context. Further on, for each of the barrier functions, we need to understand and map and establish the integrity and functional requirements. And this is then coming back to Matthias and what he said about security level. It's all linked together. So if you're running a project, establishing a new process plant or a new system, compliance management and ensuring that you're compliant with the cybersecurity requirements and overall process safety requirements is something done in the project phase. And once you are in the operational phase, it's important to have a robust way of monitoring status of the barriers and performing regular verification of the barriers. And as Matthias pointed out, there is a need to do repeated activities and reviews to make sure that the cyber threats and the risks are that we have an overview of it, and that the barrier functions are still relevant to avoid that barriers are disabled, impaired, or degraded. So including overall ICS cybersecurity into overall barrier management processes is important. And with those words, Matthias, we are reaching the end of this part of the webinar, and we are on to the more Q&A session. And we will try to reply here to questions. And if you have any questions, feel free to send them in now. And I see that we have got a couple of questions here that we can talk about, Matthias. And I think the first one is for you. So we have a question here on ICS systems and internet have been present for many years. So why is there now an increased attention from regulators and stakeholders related to ICS cybersecurity? And Matthias, this is linked to what you talked about initially. So do you want to quickly elaborate and summarize some key takeaways here?
Yeah, it's related to the increased connectivity, the IT/OT convergence, as I talked about, and remote access and cloud integration and so on. It's also, I think it's also based on, well, we have real accidents has happened in the past, like Stuxnet, Triton, Colonial Pipeline, and some ransomware in manufacturing, and probably also a lot of things we don't hear about. And there's also like a regulatory pressure. So the governments around the world sees critical infrastructure like something that is should be under national security. So it's more protected, and yeah, I think that's the main point.
It's a good point, Matthias. I see that we also have another good question here. This is a question we also are getting frequently. So who should participate in cybersecurity risk assessment? So you have been talking today, Matthias, about the high level and the detailed risk assessment. We also have other methods, vulnerability gap assessments, and so on. And what type of disciplines are typically involved in the assessment? Do you want to say some words about it initially?
Yeah, well, it's important to have a multidisciplinary workshop when working with these systems. So it's control, automation, process safety, functional safety, cybersecurity experts. It could be both from the IT and the OT domain, asset owners, and also like vendors if they are providing a system for the overall OT system.
So the main message here is, what you're saying is that this is not an activity you do on your own. It's important to have a multidiscipline focus to make sure that it's a holistic and integrated approach, and that you both have the process side, but also the IT OT engineer side. And that's also related to one of the other questions here is which engineering discipline should have the overall responsible for ICS cybersecurity? And I would say that here there is nothing right or wrong. It could be different disciplines, and whether it's IT initiated or driven, or whether it's automation, instrumentation, it all depends on the organizational structure and the way of building up an organization. But coming back to what you said, Matthias, here it's important that there is a multidiscipline approach. So if it's driven and facilitated by the IT department, then it's also vital that the process side of it and process safety, technical risk is part of the process. We have another question here is how do you think this area will develop in the future? I can just say some words initially, Matthias, unless you want to jump onto it. But it's, I would say it's related to what I said earlier on in the presentation. In a couple of decades ago, there was a development of a framework, risk-based methods and so on for instrumented safety functions due to the rapid development in safeguarding process plants by a combination of mechanical instrumented layers of protection and so on. So there was a need to make a structured approach and to ensure that there is an acceptable risk. And to me, it's comparable what is happening within ICS cybersecurity. So due to the convergence, connectivity, and so on, there is a need to have a structured and thorough way of doing risk assessment so that no blind spots are left open or port openings still exist. So I would say that the methods will further develop and we will see a rapid development within the area. But Matthias, I'm looking forward to hear your thoughts on it.
Yeah, I think we'll also see stronger regulation. Well, we have a developing geopolitical landscape, right? So we'll see stronger regulation. We'll see more audits, I think, and we'll also see like more integration of IT OT, as I mentioned in the presentation, because we see developments in both sectors. So there is opportunity to get from integrating here. So I think, but I think we will see a lot of more regulation on this part to ensure that we are keeping this system safe, especially when it comes to the critical infrastructure.
Great, Matthias. And finally, here we have a question which is good and related to functional safety. So in the design and reliability calculations of safety instrumented functions, so what we call SIFs, should cybersecurity considerations such as the potential for cyber threats or attacks that could impact SIF performance be integrated into the SIF design process? And if so, how can we account for these risks in the design and reliability assessment? And first of all, a safety system will consist of multiple SIFs. So a safety system can have multiple instrumented functions, so-called SIFs, which are referred to here. And when you design a safety system, you design typically against IEC 61511, and that standard is requiring the end user and the SIS integrator to perform cybersecurity risk evaluations. So cybersecurity needs to be taken into the design process and the overall evaluation for the safety system. So to me, it's more on the overall safety system design, maybe then down to the SIF calculations. But there is obviously a need and important to include cybersecurity evaluations and assessments into the design of safety systems. And that's then we have the 62443 standard, Matthias, and equivalent method that can be used if you want to add something here.
Yeah, I think we have the security level assignment. So based on the worst case consequences from the assessments, we assign a security level, which could be seen as kind of an equivalent to the SIL levels. So I think also here it's important to mention that the cyber threats are they're more like systematic failures and not random hardware failures. So maybe they're more managed through design and process and assurance than probability here, right?
I totally agree, Matthias. I agree. I see that we are running out of questions, or we can take one. If you give me some seconds, Matthias, I will just see if we have any incoming questions. Let's see here. So we have a question here. What are your thoughts on the security of describing your information security barrier systems, as this could pose a vulnerability in itself if you, for example, highlight gaps in your barriers? I'm not sure if I fully follow the question, but I think this IT-OT convergence that you pointed out earlier, Matthias, it's important to have a holistic approach into risk management to make sure that all risks in the interface between IT system and OT system is captured, and information security is also part of it. Do you want to elaborate, Matthias?
No, I'm not sure about the question totally, but is it could be interpreted as if you're describing your security measures, security barrier system, then by itself, by just describing it as having it as a documentation, is that a risk in itself, or does it pose a vulnerability to have this documentation? It could be, but I don't think you're publicly disclosing this kind of information, and it's about working with trusted partners, because documentation is essential for effective risk management and improvements.
Yeah, and we have an additional statement related to the functional safety related question here, which is a good comment. To add to the question of integrating cybersecurity considerations in SIF calculations, in my opinion, the main difference between cybersecurity and functional safety is the difficulties related to quantifying likelihood for cybersecurity, as already mentioned by Matthias, but likewise quantifying risk-reducing measures. Any thoughts on that? And it's a good question, and that's the bottom line on what we have talked about here today. That likelihood, adding likelihood into the calculations is challenging when we're talking about cybersecurity, since we are talking about intended actions. And that's why you mentioned, Matthias, when we're talking about the requirement from IC 61511, it's also about making sure that you have a robust safety instrumented system design that is minimizing any potential for unauthorized access. Anything to add there, Matthias?
No, it is the main challenge is that we don't have the hard data. So, and also that the attackers, they adapt, and the systems we're looking at is individual systems from individual organizations. So the likelihood is very difficult to determine. And yeah, maybe it's also relevant to look at the effectiveness of the cybersecurity countermeasures that is implemented, and not just the likelihood. So it's a difficult exercise, this one.
Indeed, Matthias. So I see that we are starting to run out of time, and for some of you it's approaching lunch hours, so I suggest that we can wrap up the webinar now. But thanks a lot for joining today's webinar, and we will keep on publishing both insights and webinars related to this topic and other topics related to risk and safety for different industries. So please stay in touch with us on our LinkedIn page or our webpage, ors-consulting.com. And if you have any further questions, or if you something you would like to discuss, please contact us directly. So once again, thank you all for joining today, and wish you all a nice day.